Take it away.
Okay, so thank you for this invitation. It's great to be part of this panel. So I just want to begin by saying recent IPCC report stresses that to remain within 1.5 degrees, we need to reduce greenhouse gas emissions by almost 50% by 2030 and reach net zero by 2050. So a climate emergency has been declared. So the need for addressing whole life emissions towards net zero is emphasized in many schemes worldwide, whereas it's leading to a confusing plethora of terms and definitions. So to address this confusing plethora, we in the IEA Annex 72 have conducted an international survey of net zero schemes in 35 countries worldwide. What we see is that energy is still the primary metric in 60% of those schemes, yet 40% have now shifted to greenhouse gas emissions. So I just want to share with you some of our experience from the Research Centre for Zero Emission Neighbourhoods and Smart Cities. So basically a Norwegian approach to achieving a national goal to achieve net zero. So the vision of the ZEN Centre is to create building and neighbourhoods with zero greenhouse gas emissions. So effectively, emissions from renewable production must balance embodied emissions and operational emissions across the whole life cycle of the building. So a net zero energy building produces the same amount of energy as its demand. So the green balances the red shown in the graph. A net zero emission building balances, the balance is measured in terms of greenhouse gas emissions across the whole lifetime of the building. So it's including the blue part, embodied emissions. In recognition that we're not all at the same scale, that went very fast, that we created the ZEB Ambition Levels to across the whole life cycle of the building. So it goes from the lowest, which is a balance for operational emissions, right through to the end of life. So in terms of developing our ZEB pilot projects, we also have developed a stepwise approach based on Trias Energetica. But the key emphasis is always on passive design strategies, reducing energy efficiency as low as possible, and then balancing that with renewable technologies. So the importance of including embodied emissions is actually found in the results from our ZEB pilots. So we have 9 pilots which are built, and what you can see here is the orange is the operational emissions, and grey is the embodied emissions from materials. So we see a 70-30 split. Another interesting finding was that across all the ZEBs, we see that the key driver for high emissions was the PV, the concrete, and the insulation used. But obviously, as a designer, you need to make a view on, you need the PV, but you can reduce emissions across the other materials. Another important fact was that we needed to use dynamic emission factors for the grid mix, because even though Norway is almost net zero emissions for the grid, there's considerable export and import across countries, and we need to consider the future decarbonisation of the grid mix. So basically that slide is showing, basically we need to include, consider the export and import of electricity in and out of the country, right through to Europe and back in again, which is higher carbon, and the future decarbonisation of the grid. So we use a ZEB emission factor. So how do we bridge this gap between design and research? So we need to really find ways to use technology and to integrate, robust calculation methodologies into the design tools. So over actually 10 years ago, I can't believe it now, I started with this development of an Excel-based embodied emissions tool. This is just showing version 1 of it. But this was really useful for us. Instead of having a black box approach, having the Excel allowed us the flexibility. Wow. Okay. The point with the Excel tool was it became the ZEB tool, which was then used to assess the performance of the ZEB pilots. Then we started to look at how we could dynamically connect that to 3D tools using scripting, and we also included EPDs and generic data. So I'm showing a series of slides here that show the evolution of this. So this is one early stage concept where we connected Revit BIM to the ZEB tool using Dynamo scripting and explored the use of color to communicate to designers about high and low emissions. The second stage was actually starting to work with a dashboard, so the user interface. Because for architects and designers, the scripting part is quite difficult. So the idea was keep the engine in the bonnet, under the bonnet, but work with that interface side of it. And we also, again, like I said, started to work with the use of sliders, which were connected to an EPD in the engine, let's say, but you could easily change the form of the building blocks and also look at the impact on embodied emissions of different locations of materials and how you show the impact for the transport emissions. Then I really started to think about, well, how do we cope with that shift in scale from building to neighborhood, and also the complexity with multiple KPIs, and how do we communicate to diverse stakeholders? So in these two projects here, we started to look at the integrating virtual reality to engage diverse stakeholders. And here you're seeing a dashboard approach where we can easily, through the click of a button, shift from building scale right through the bottom left is showing you neighborhood scale. So I currently have a PhD researcher who is working with immersive technologies connected to that engine that I spoke about before. And we're really quite excited about this work to communicate to diverse stakeholders. So thank you.
Thanks, Aoife. Good job.